Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, so today what I want you to focus on first is I want you to do this scrimmage problem right here. So it's attached on the PDFs. So I want you to do A, B, C, D, and the bonus. And the answer will be on the other PDF that says solutions. So I want you to try this on your own first. See if you can do the whole thing. Just like our free response would be on the AP Calc exam, and then check your answers, and then obviously upload all of your notes. You don't have to get the actual value, just get the integrals and you're good. All right? Now, here is the first part of the lesson today. So we're going to do the first part today and then the next part tomorrow. Okay? So volumes of revolution part 2, holes. Let's start with one more from yesterday. One from yesterday? Woohoo! Now it's my time to shine. No, I said yesterday, not yesterday. Oh, okay, never mind. Here you go. First one. Find the volume of the solid generated by revolving the region defined by y equals x squared plus 1, x equals negative 2, and x equals 2, and the x-axis about the x-axis. So pause the video, write that down, da-da-da, do it. Here we go. Here's me. All right, cool. So first things first, we need a picture. Yeah, we need a picture. Y equals x squared plus 1. So that starts on 1. And you got a parabola. Looks like this. Y equals x squared plus 1. There you go. Okay, and so x equals negative 2 is over here, and x equals 2 is right here. And the x-axis is another border, so it looks like this thing right here. So this is the area that we're going to rotate. Okay, so we're going to rotate it about the x-axis. So, draw a mirror image, and then bam. When you rotate it, you're going to get a bunch of circles, right? A bunch of discs. Looks like that. So it's going to revolve around there, and you're going to get like a little horn shape with opening on the left side, opening on the right side, like that. A little narrow in the middle. Okay, so draw a slice like this, and it looks like this is your radius. Pause the video, see if you can do the integral. All right, let's see what we got. So the radius would be the top minus bottom, which is x squared plus 1 minus 0. The width is dx. So the volume of a slice is going to be pi r squared times dx, the area of the base times the height, or the width, so it's pi times x squared plus 1 squared dx. And so now the entire integral, the volume of this horn-like shape, is the integral between negative 2 and 2, the accumulation of all of these disks, all infinite amount of disks right there, infinitely small, equals pi times x squared plus 1 squared dx. Did you get it? Yeah, I know you did. Nice job. Here we go. Here's the new ish right here. Check it out. So, find the volume of a solid generated by revolving the region enclosed by y equals x squared plus 1. Okay, same thing. And the line y equals 5 about the line y equals 5. Okay, so same problem, but check it out. So, I forgot to say that x equals 2 and negative 2, so I'm going to go out the same thing as that. All right? So, boom, boom. So y equals x squared plus 1 looks like this, just like before. Parabola, y-intercept is 1, so this is y equals x squared plus 1. And the line y equals 5 looks like this, straight across. So this right here, goes forever in both directions. Y equals 5. Okay? So now I'm taking this area here and I'm revolving it around this line y equals 5. So now this right here is being revolved around this part right there. Okay, so let's draw a little slicey slice. So, So the radius, so when you do the radius, you always go with the original area. So this was the original area down here. So the original area down here, that's why I have to focus. So that would mean that, you see, this would be the radius of all the disks. So this would be the radius, this would be the radius of all the disks. So the radius is actually on the bottom half is where we need to get it, okay? Because that was the original area, which is the bottom half of the disks when they rotate around. Okay, so in this case, this is the area, so that's the top minus the bottom. Top minus the bottom. And so that's going to be the top, which is 5 minus, parentheses, x squared plus 1. Bam. So that's your radius right here, because that is the area that's being rotated, top minus bottom. Bam. Okay, so the volume of the slice is going to be pi r squared dx, which is pi times 5 minus x squared plus 1, close parentheses, all squared, dx. Cool. Questions about that so far? All right, so now we have the integral, the top and the bottom, so I need to find these two. I said it was 2 and negative 2 before, but is that? I don't know. Let's see. Set the equations equal to each other, see where the points of intersections are. X squared plus 1 equals 5. Yeah, minus 1, minus 1. I was right. X squared equals 4, and so 2 and negative 2 squared equal 4. So this is negative 2, and this is 2 on the x. So my integral is between negative 2 and 2 of pi times 5 minus x squared plus 1 squared dx. And if you really fancy, this is the volume, you can just simplify that a little bit in there if you want. The integral between negative 2 and 2 of pi times 5 minus 1, which is 4, minus x squared, when you distribute the negative, squared dx. Both of those are the same thing, both acceptable answers, we good. Cool. All right, next one. Bam. I'm going to do this one. You're going to do this last one by yourself. See if you can do it. Find the volume of a solid generated by revolving the region enclosed by y equals x squared plus 3, y equals 1, x equals negative 2, x equals 2, about the line y equals 1. All right, a lot of stuff. Let's take it step by step with a little drawing. All right. Y equals x squared plus 3. So that looks like this. Yeah, I said it was 1 before, but that's 3. Just draw it. Doesn't have to be the exact. So that's 3. This is y equals x squared plus 3. Okay. Y equals 1 would be here. Here's y equals 1. And x equals negative 2. And x equals 2 is this. So it looks like it's this area we're talking about right here, between the parabola and y equals 1. And so that's being revolved, not around the axis, but revolved around the line y equals 1. Important to notice that right there. So I'm going to draw a mirror image right here. And so we have the same kind of shape as before, where we have a narrow inside, and then it sort of has like a opening on the outside. Although this is entirely solid. This is entirely filled in. There's no hole in the middle. So here we go. So draw a slice. This is dx. And the radius, so this is the area that we talked about before. So that's on the top. So the radius would be from the top. That's what we're looking at, from the top. All right. So the radius from the top. Don't do the radius from the bottom. You're going to mess the whole thing up. People last year did that. Don't do that. So it's going to be top minus bottom here. So the top is the parabola and the bottom is the line, y equals 1. So that's going to be x squared plus 1 minus 1. Top minus bottom. Okay, so now the volume of a slice is going to be pi times radius squared, plus 1 minus 1 is just x squared. That's 0. So x squared dx, like that, equals pi x to the 4th dx, if you want to simplify even further. So my full integral, the volume of the whole thing, is the integral between negative 2 and 2 of pi times x to the 4th dx. There you go. Cool. All right, last one. Here you go. You're going to try this one on your own. Find the volume of a solid generated by revolving the region enclosed by y equals 2x plus 1 and the y-axis and the line y equals 5 about the line y equals 5. Pause the video, see if you can do it. I'm going to complete it on the other side. All right, let's see what we got. Let's check it out. All right, so first I'm going to draw the picture. Y equals 2x plus 1. So here's 1. 2x means it's got kind of a steep slope right there. Y equals 2x plus 1. Got it. Y equals 5. If that's 1, then 5 would be up here. Y equals 5. And we're revolving this about the line y equals 5. And so we're revolving it around this. So I need to draw a little mirror image right here. And then here is where we're rotating like that, revolving it. So let's do a slice. There's a little slice. Where is the area we're talking about? That's on the bottom. So here's my radius on the bottom. And that's always top minus bottom. Top minus bottom. So the top is the line here, and the bottom is the diagonal line, which is the 2x plus 1 function. So that's going to be 5 minus, parentheses, 2x plus 1 is my radius. Okay, so now the volume of a slice is going to be pi. Let's distribute this negative, shall we? 5 plus negative 1 is 4. And minus 2x squared dx. So now my final integral, my volume of the entire shape right here is, I don't know what this is. So we have 0 obviously here, but what is this point here? How am I going to get it? Yeah, you're going to set them equal to each other. So that's going to be 2x plus 1 equals 5, minus 1, 2x equals 4, so x equals 2. 2 times 2 is 4. So this is going to be 2 here. Cool. So 0 and 2 of pi times 4 minus 2x squared dx. There you go. Excellent job. Excellent job. Make sure you get that scrimmage done. We're going to continue this tomorrow. We're going to make it a little more challenging. Great job right now. Miss you guys.